Hi everyone, welcome back to the second part of fifth session of our open course. We continue this topic about the SC test. In this chapter, I will introduce you how to complete a short circuit test. The important steps are listed in this slide, as we can see. So the first step, actually the cable connection is quite similar compared to double post test. The only difference is that the load inductance is replaced by the copper plate or short cables to simulate the SC condition. After that, we should power our GDU first, check if gate voltage is correct, and give a single pulse to check whether the waveform is correct or not. Please remember this step cannot be ignored. It is very important. And then in the third step, we should increase the voltage to a relative low value to check the performance of our test probe and evaluate the circuit inductance. Normally, this inductance level is in 100 nanohenry and the voltage is in 100 watt. In actual test, we will use 20 watt, and also from the this inductance value, you can know that we can only simulate first type short circuit. After these three steps, we can start increasing voltage and record the data. Please always keep in mind only single pulse to our DUT, and the DC link voltage depends on your actual requirement. After the data recording, first thing is always discharge the system. If you want to repeat the test, 5 minutes pause is then necessary, because I mentioned also in the first part of this course, the heat generation during short circuit is quite high, and the module needs time to be cooled down first. This is the important steps for short circuit test. Then in this slide, I listed the data needs to be recorded during the test. The first parameter is the maximum collector emitter voltage, which cannot exceed the threshold of the module. The next parameters are short circuit current and our maximum gate voltage. Same like in double post test, the gate voltage must be maintained in a reasonable range. Otherwise, the gate will be damaged. And the next four parameters are our energy, the short circuit time, the rate of the current, and the maximum power during the short circuit case. And for the first type short circuit, we will measure voltage, current, and the energy loss, or another word, the heat generation, to evaluate if all parameters are in our safe operation area, the SCSOA. And for second type short circuit, we will record the gate voltage and the short circuit time. The target for us is now to check the driver characteristic. So this is a difference between these two different types of short circuit. In next slide, I prepared a sample pre-testing waveform. We provide a 20 volt DC link voltage. This pink line, and the module is a 1700 volt and 1600 ampere module. Gate voltage is blue here, and the red line is our current. So you can see that the current is already 1000 amperes on such low voltage. This is why we say short circuit has potential risk. By this pre-testing, we can check the status of our platform, check the signal connection, probe connection, and if everything is ready, then we can start increase the voltage. So we go to this slide. This is a sample waveform of a short circuit. We give a 12 microsecond pulse, and the DC voltage is 1,017 watt. We can simply analyze this waveform. So at the beginning, we turn on the module, the collector emitter voltage, the VCE, will start decreasing dramatically, and at the same time, because of the low inductance in our circuit, the current increase rapidly from 0 to quite high value. It is almost 2 times of our nominal current in 5 nanosecond. Therefore, as I mentioned in last part, the IGBT didn't go to saturation region but span it, and the desaturation finished when the voltage, the collector emitter voltage, back to our DC voltage. This is what you can see here. The current start be keeping almost stable and start decreasing quite slowly. Thereafter, we can turn off our modules. Then there might be a question why we didn't turn off our module when current is increasing. The reason behind it is a little bit complex. So generally, one reason is that we cannot imagine the exact status of module during this current increasing process from cutoff region to active region. Therefore, it is dangerous to turn off the module here. And another point is that we need to leave a filter time to avoid a possible fake detection of the short circuit. If you remove this filter time, maybe the SC protection will be activated during normal operations. This is what we don't want to see. Therefore, we don't turn off the module directly here, and recorded data is here below. The current is almost 9,000 ampere, 5.6 times higher than the nominal current, and the gate voltage is 15.6 volt. Maximum collector emitter voltage is 1160 watt. But they are all in our short circuit safe operation area. Besides two-level system, we have also mentioned a three-level system. Here in this slide, I also gave you the samples of it. We can see that if we take a view in this power, it is in megawatt level, which is extreme high. This is why we say that short circuit test has potential risk and can damage our module. So you can take a look into this waveform, and then you can have a general impact how the waveform should be looks like. Okay, this is a general instruction of SC test. Now in the end, I want to give you some tips during the test. The first point, keep safety, ensure the safety. Isolated gloves, shoes, explosion proofing of the duct are necessary. The second point is that the cable should be as short as possible from pulse signal generator to our GDU. The third point is that the bus voltage should not be too low. Then we can use the relative low voltage for the pre-testing, but in the real test, use a high bus voltage. It is important to avoid the damage to the modules. And the next point is that the short circuit pulse setting cannot be too short. We need to let our module desaturated. It is the reason behind it. And the next point is that the gate voltage can be reduced appropriately for the first time, for the first test, because maybe you are not sure what will happen if we use 15 volt gate voltage. Maybe the current will be quite high, and then cause explosion. If you are afraid of that, you can use firstly use a relative low gate voltage to check if everything is okay. And the next point is that short circuit test requires attention to the gate signal of the complementary IGBT. It is also important that we need to check the complementary switch. In the last point, in case of IGBT explosion, be sure to cut off the main power switch first. So if you meet explosion, don't be afraid. Firstly, discharge your complete system. It is very important. Just discharge your system and make sure that there is no power left in your system. So the key point here is that the safety is always the most important thing for us. Okay, this is all content for this course. We have a general view in the SC test. So see you in our next video. Bye.